affects women globally, and in 2025, approximately 300,000 women will be diagnosed with breast cancer. So BRCA1 and BRCA2 are tumor suppressor genes, and if they're mutated, they will lead to the cell dividing uncontrollably, which will raise cancer risk. And early detection through genetic testing will improve survival rates and reduce mortality. But there are a lot of racial and ethnic disparities I will be covering in this presentation. So this is a chart by the American Cancer Society, and the pink line, which represents the Americans, including Hispanics, shows how the incidence rate is much higher as compared to African Americans, but the mortality rate of Americans is much lower, which shows how like later stage testing will reduce and will increase mortality rate. So some functions of BRCA1 and BRCA2 mutations, so they genes, so they're tumor suppressor genes and they help with DNA repair, the cell cycle regulation, and transcription, which is really important for protein synthesis. And if you inherit these mutations, it can lead to a 70% increase of breast cancer. So genetic testing for these will allow to see if there's also a risk for the family to get this mutation and for early preventive care like surgery and for screenings. So for my literature review, I looked over a lot of studies that showed the ethnic disparities in BRCA1 and BRCA2 testing, and I found that African Americans and Hispanic women had a much lower testing rate, even when they were eligible due to certain barriers. And this delayed testing led to a very high mortality rate in these races. So some reviews that I found, they mainly focused on the social, cultural, and societal barriers of breast cancer testing. And they also highlighted a lot of medical mistrust in the African community because of past occurrences of breast cancer. So I made a chart about all the data I collected for the social cultural barriers. So as you can see, Americans had a like much higher access to DBT screening. But even when it was available, his Black African Americans didn't use it as often as Americans did, which just shows how these barriers affected them. And then for systematic barriers, which are barriers that are like implemented in the system itself, like cost and insurance and like transportation issues, it was also very prevalent in African Americans as compared to other races, African Americans and Hispanics. So, for my methodology, I looked over probably over 100 articles and clinical studies from sources like PubMed, clinicaltrials.gov, and Google Scholar. And I focused on races, but specifically focused on African Americans, Asians, and Hispanics and Americans. And I also focused on BRCA1 and BRCA2 mutations and the prevalence in them. So for my results, I consistently saw that African Americans and Hispanics had much lower BRCA1 and BRCA2 testing rates, and of course later stage diagnosis, and these factors reduced a lot of testing access, which led to high mortality. So for my methods, I used quantitative methods, so I analyzed a lot of statistical data on these mutation rates. And for my qualitative methods, I explored cultural and systematic barriers, and I created charts from using all of these methods. So in conclusion, BRCA1 and BRCA2 mutations are very strongly linked to having worse cancer outcomes. And there are a lot of solutions like having testing like areas around like all around the world, not just in specific areas, and having culturally sensitive genetic counseling to reduce the stigma around it. So getting genetic testing is very essential for racial justice in cancer care. And with Gifted Gabber, after this entire program, I think I was able to get much better at like having better critical thinking. I was able to like look through long paragraphs of text and articles and understand them, and I was better conducting research and looking online, and I was like able to use more sources as well. And I'd like to thank Dr. Farhad and Professor K for helping guide me through this entire research article and Coach Joe and the Gifted Gabber team. So thank you.
Wonderful. You can stop sharing now. Great job. Very good presentation. Shows your passion, and you just finished ninth grade, right? And it shows a lot of maturity. Dr. Prahlad, a question for Ashna.
Yeah, great job, Asna. Congratulations. So I want to hear what's being done. Are there any steps being taken? Did you find anything positive from your research to dismantle the barriers that you mentioned?
Yeah, I think more screenings across like places with higher African American communities. Um, yeah, so I think a lot of work has been taken, especially with clinical studies too.
Mm-hmm. All right. Yeah, great job. Congratulations.
Wonderful. Let's have a question from Professor K. I think she dropped off. I'm so sorry. Okay, so thank you, Ashna. Two questions for Ashna. Let's go on with our next student, which would be Mahika. Mahika, are you here? Okay, Mahika is not here. Let's go with Saranya. Yeah, great. I see you. Wonderful. Thanks for joining in. Yes, sweetheart, get started. Yes.
Hi, my name is Saranya, and I'm a freshman at Irvine High School in Irvine, California. And my research paper is about the role of diet in the development of pancreatic cancer, mainly focusing on ultra-processed foods. To start off, my research question was, how do ultra-processed foods affect pancreatic cancer development? While treatment methods have showed some improvements over time, pancreatic cancer is still known as one of the most aggressive cancers with a 5-year survival rate of only 20%. This makes it really important to take precautions to lower the chances of developing cancer. The objective is to analyze the correlation between diet, especially ultra-processed food, and the cancer rate. This topic is important since we don't fully understand how these foods affect the pancreas. Being aware of this could help people make better food choices and even reduce cancer risk in the future. For my literature review, I've looked into the ultra-processed food consumption of many different countries, but mainly focused on the United States, UK, Brazil, and India. Additionally, I've also looked into the pancreatic cancer incidence rates in these countries. On the slide, I've listed 2 clinical studies that have similar aims of proving that diet is a factor of the rising incidence rates. The first one I found was physical activity and nutrition to halt elevated risk in the Pancreas Interception Center. The main idea of this clinical study is to assist in implementing an easy-to-adopt lifestyle intervention that optimizes patient outcomes and minimizes the risk of pancreatic ductal adenocarcinoma. This trial is recruiting and is expected to be by November 2027. The second clinical study listed here is lifestyle and breast cancer. The main purpose of this is to assess the efficacy of a nutritional intervention with the Mediterranean diet with extra virgin olive oil for the prevention of relapses among women with early breast cancer. This ongoing study supports the direct research by exploring how a whole food diet like the Mediterranean diet with extra virgin olive oil might help prevent cancer from recurring. Ends with the idea that reducing ultra-processed food intake could help lower the risk of developing pancreatic cancer through similar biological pathways like inflammation. This study is expected to be completed by December 2026. Now I'll talk about the methodology. For my data collection, I reviewed papers from PubMed and other reputable sources like Google Scholar, and I mainly focused on finding papers that connected ultra-processed food consumption with conditions that are known to increase the risk of pancreatic cancer. For example, I found papers that connected ultra-processed foods with obesity and chronic inflammation, along with papers that connect obesity or inflammation to pancreatic cancer. One of the main limitations of this study is multiple dietary factors. Even though ultra-processed food plays a huge role in the development of pancreatic cancer, there are other foods like meat that increase the risk of developing cancer. For example, in 2012, Japan had an age standardized rating per 100,000 of 8.89, which was relatively high compared to other countries. When comparing it to the United States, Japan had a higher age standardized rating but had a lower ultra-processed food consumption rate than the United States. However, Japan consumed almost 3 times more seafood than the United States. So there are like multiple foods that could increase the risk of developing pancreatic cancer. Additionally, there's also genetic predisposition, where some individuals have a higher chance of being diagnosed due to a genetic risk. And also, lifestyle factors such as smoking and alcohol can affect cancer development. And another limitation is that there are limited clinical studies and they haven't posted their results yet. So coming back to my research question, which is how do ultra-processed foods affect the development of pancreatic cancer, we can conclude from the available limited research that there is a clear link between ultra-processed food consumption and pancreatic cancer risk. Therefore, reducing ultra-processed foods, which contain added salts, sugars, unhealthy fats, and more, can make us less prone to cancer. Additionally, dietary education on ultra-processed foods could aid cancer prevention. I'd like to thank Dr. Prahlad and Professor K. Both of them have been extremely helpful as through this process of writing a research paper. Coming into this program, I've never written a research paper, so I wasn't really sure what to expect. Overall, this program has been such a great experience for me, and it allowed me to write about the topic that I'm passionate about. And I'm so glad that I got to go through this experience of writing a research paper with Gifted Capper. Thank you.
Awesome. Awesome, Saranya. A question from Professor Prahlad.
Hey, great job, Saranya. Congratulations. So in your research, did you find also look at like what compounds are there or molecules in all processed food and what's the mechanism that actually leads to cancer development? Did you find anything?
Yeah, so I found that like sugar is one like component in ultra processed foods, and I found that consuming large amounts of sugar or like high sugar foods may increase the risk of pancreatic cancer due to frequent spikes in like blood sugar levels that it causes. And emerging research also suggests that elevated blood sugar contribute to development of pancreatic cancer.
Okay, so blood sugar, it's related to inflammation also. Okay, note that. Yeah. All right, great job. Congratulations.
Great. Okay, so wonderful. I don't think Professor K is here. She may have some issues, but thank you, Saranya. Wonderful presentation. Folks, 2 questions for the students presenting. Please pay attention to others' presentation as well. Okay, so let's go with Akshara. Akshara, you here?
Yeah. Hello.
Okay, great. Akshara, go ahead.
1 second.
No problem.
Is it showing? Hello?
Yeah,
We can hear you. Go
we
Is
ahead.
can
it?
hear you.
Can I just
No,
send the
it's not showing. It's not
It's-
showing.
Yeah.
Can I send the link in the chat?
Yes, yes, you can send me a link and I will share.
Okay, I sent the link.
Just gonna open it. Hold on. Yeah.
So good afternoon, everyone. My name is Akshara Danamudi. I'm a student at the George School in Pennsylvania, and the topic I chose is liquid biopsy and early detection for neuroblastoma. Next slide. So neuroblastoma is the most common extracranial solid tumor in children, and it accounts for approximately about 8 to 10% of pediatric cancers, and it primarily affects infants and young children who are like around the age of 10 to like 15, and it is also a big factor in cancers for children. And traditional methods for detection are imaging and tissue biopsy, which are mostly invasive and delayed and can sometimes have false cases and also miss early and minimal diseases. So these challenges highlight the need for more effective and non-invasive diagnostic tools, which is why I chose liquid biopsy. So liquid biopsy offers a promising solution to these challenges, which, unlike the traditional methods, it involves analyzing bodily fluids like blood or urine and detect specific tumors through biomarkers or other markers like the circulating tumor DNA, tumor cells, and microRNAs, as well as exosomes. So the questions for my paper were, can liquid biopsy improve early detection of neuroblastoma in pediatric patients? What specific biomarkers are most reliable in detecting neuroblastoma, and what are current technological and clinical limitations to implementing liquid biopsy in pediatric oncology? So the objectives of my research were to review the scientific basis and clinical evidence supporting liquid biopsy in neuroblastoma, to evaluate the potential of different liquid biopsy biomarkers for early detection and disease monitoring, and to analyze current challenges and identify future directions for clinical integration. Next slide. So through my literature review, I focused a lot on past and current review research papers, and I also found a few clinical trials. So this image here is showing different biomarkers that are used in liquid biopsy to detect cancer. So we can see there's like the mRNA, ctDNAs, and the circulating tumor cells. So the challenges with neuroblastoma is that includes like heterogeneity, making it difficult to detect early and monitor consistently. So while traditional diagnostic methods can be effective, it also has limitations like limiting scans can miss early stage tumors, and biopsies are also invasive and challenging, particularly for children who have more weak bodies. Um, so I found studies to confirm that ctDNA and exosomes can reflect the tumor-specific mutations. Exosomal mRNAs like MIR21 and MIR155 show promise as diagnostic markers, and circulating tumor cells have been associated with poor prognosis when presented in higher counts. So I also identified some weaknesses in the literature, which was a lack of standardized biomarkers and assay protocols for pediatric use, small sample sizes, and limited longitudinal studies in neuroblastoma, and underrepresentation of pediatric specific clinical validation trials. Okay, next slide. So for the methodology, I conducted systematic reviews of studies from PubMed, ClinicalTrials.gov, NIH, and Google Scholars. And the keywords I used were neuroblastoma, liquid biopsy, ctDNA, exosomes, and early detection. So I focused on the targeted pediatric populations that involved liquid biopsy and neuroblastoma, and evaluated like the validation of biomarkers. So this was also an issue because since this is a relatively new study with liquid biopsy, there weren't as many recent studies about this. So I also had to just use some separate studies that were specifically just on like liquid biopsy, not related to neuroblastoma. So my findings were, I found that the ctDNA can identify critical genetic alterations such as MYCN amplification and ALK mutations. So it uses digital PCR and next generation sequencing to help identify early genetic changes linked to neuroblastoma, even before clinical symptoms may appear. And then I found with CTCs they're correlated with prognosis with higher level associated with more advanced disease and poorer survival rates, and exosomes, as well as which contain critical tumor specific proteins. And they're also an emerging area of interest for non-invasive biomarker analysis, and their role in disease was monitoring and prognosis in becoming more evident, since the other ones weren't as evident in early stages. So some challenges I had with this were the major barrier was low abundance in the circulating biomarkers, apparently particularly in early stage diseases. the tumor heterogeneity, like I mentioned, where it complicated the identification of many biomarkers as the tumor may evolve over time or vary between different patients. And there was also a lack of standardized protocols for biomarker analysis and validation in pediatric settings. So next slide. So to conclude, my research addresses the crucial question of whether liquid biopsy can improve early detection in neuroblastoma, and my findings showed that biomarkers such as ctDNA, CTCs, exosomes, and mRNAs hold promise for non-invasive early detection and disease monitoring in neuroblastoma. And however, there are several barriers, including technological limitations and lack of standardization in these clinical protocols. So key contributions of my research was that I synthesized like current literature on the feasibility of liquid biopsy for neuroblastoma detection and monitoring, and I also highlighted the critical biomarkers. So I also identified the gaps in clinical application and suggested some pathways through liquid biopsy, especially in pediatric oncology. So I also emphasized future directions. Again, my professor also helped me a lot with finding the clinical trials because I had problems since a lot of them were either from a long time ago or they were still ongoing, and most of them also just got cut off for some reason, which we looked through, and a lot of them were ended since they couldn't find as much information. So I just looked through some current um, clinical trials to help with future directions, which because there's a need to standardize biomarker panels for pediatric blastoma. And I also looked into integrating AI-based technologies and analyzing liquid biopsy data and enhancing personalized treatments. Okay, next slide. So finally, I just want to talk about my research experience. So in the beginning, I feel like the lectures for me especially made me easier like for me to choose what topic I wanted to do. I knew I was interested in like neuroscience and something with the brain, but then with the neuroblastoma, I wasn't really sure where to take my research. So then um, Professor Prahlad suggested that I focus on liquid biopsy since it's a new and emerging non-invasive method. So I thought that was really interesting. And he also helped me a lot with finding, like I said, the clinical trials, which are they lack a lot of clinical trials in this area. So he helped me a lot with finding those trials and also integrating them into thinking about the future of this topic. And finally, Professor K supported my paper in many ways because I wasn't really sure in the beginning how to write a research paper, like the structure, and also as well as using different sources, validating and making sure my sources are credible. And I also want to thank this program because this gave me a lot of insight into also what I want to focus on in the future. And after this, I also hope to look more into this topic and maybe even talk to more professors or have a little more hands-on experience rather than looking at just second-hand sources. So again, I just want to thank everyone for this. And yeah.
Excellent. Very nice. Let me have Professor Prahlad ask you a question. Go ahead, Dr. Prahlad.
Great job, Aksara. Congratulations.
Thank you.
So you studied liquid biopsy, right? So apart from early detection, what other application does it have in cancer treatment?
Yeah.
Yeah.
So I did find some clinical trials that were exploring this now, and I focused mainly on early detection since, especially with children, it's harder to detect it for them earlier. And since this is mainly like pediatric disease, I was looking into that a lot. But again, with like, it also helps with later on. It's more like risky in some certain sense because it's also a new and emerging study. But I think I definitely do want to focus on that in my paper, like towards the end, because I know I focused a lot about early detection, but I think I need to look more into that.
Yeah, because it guides therapy also, right?
Yeah.
It tells you what kind of cancer is it, what markers are there, if they're targetable with drug or not. So maybe include that in there.
Yeah.
Okay.
Thank you.
All right. Great job.
Great
Congratulations.
job. Let's have Professor Kay with a question. Yeah.
Yeah. Hi, Akshara. I have always been interested with why neuroblastoma.
Yeah.
This
So mainly I worked with volunteering at hospitals and stuff. I worked with a lot of children, and I didn't know about the liquid biopsy aspect of it yet, but I did know a child who had neuroblastoma. So from then I was like interested in neuroscience, and I thought this was a great like pathway since it's also with cancer. So I looked into neuroblastoma, and after at first I wasn't so sure, but then after researching, I found out that it accounted for like 10% of pediatric cancers, which I think is a pretty large amount considering like how many kids have cancer. So with that, I just thought it was really interesting and decided to take that up.
really, really good choice. Good job, Akshara.
Thank you.
Yeah, and I want to remind everyone, I mean, these are high school students, and Akshara is a sophomore, and she's already a cancer expert. So great job, everyone. Phenomenal. Not only did you go through the program, but coming and presenting here. Like I always say, please take this thesis defense. The very reason we make you do this presentation is you can go to your school, please request time from your counselor. 4 minutes. Any counselor will have 4 or 5 minutes. Take the time and go and present them, and it will directly reflect in your recommendations, even teachers. So please, you've drawn a Mona Lisa, and now it's time to show the world. Please do not hide it in the basement. Okay, go on the rooftops and announce your research. Okay, so 2 questions for Akshara. Now let's go with Maunish. Maunish, you here?
Yes, I'm here.
Okay, great. I'm just going to, yes, please go ahead.
Let me just present. All right, can you see my screen?
Yes, perfect. Go ahead.
Okay. So hi, my name is Maunish Malvaduru, and I'm currently a freshman at Emerson High School in McKinney, Texas. And my research is a review article regarding plasma-based mRNA biomarkers for the early and accurate detection of small cell lung cancer, which will henceforth be referred to as SCLC. So here's just an overview of what I'm going to cover in this presentation. First, lung cancer is the most common cancer, common type of cancer globally. As some small cell lung cancer constitutes 10 to 15% of lung cancer cases, and it's characterized by aggressive growth and early metastasis. Additionally, small cell lung cancer is misdiagnosed due to the lack of symptoms in its limited stage. Seeing as SCLC is more responsive in its limited stage, it is paramount to diagnose it early. Current methods have some drawbacks that can affect accurate diagnosis, such as false positive, false negative, and radiation risks. And this basically highlights the need for a new and improved screening method for SCLC. So this pie chart here basically represents the causes of different types of lung cancer, and we can see here that SCLC is this small little slice, and in that it is almost all from smoking. And finally, the objective of this research is to review the use of plasma-based mRNA biomarkers to review its effectiveness. Since this was an analysis based on previously gathered data, I studied various articles and trials about each component of like the results, including current methods and treatments, the new method, and benefits and drawbacks for analysis methods. I cross-checked information between multiple articles to ensure clear findings and credibility for my information, as well as preventing any underlying bias that any article might have suggested. I found I have found that previous studies do indicate aberrant expression of circulating microRNAs for diagnostic markers. However, widespread adoption in hospitals is limited by factors like the need for further validation studies, standardized methodologies, and clinical decision-making guidelines. Furthermore, there's a lack of standardized methods for analysis of biomarkers, which is not good because without a standardized procedure, there can be minor variations that can affect results. So these are basically a few of the articles I reviewed that were closest to my theme. So Pinsky 2014 shares that the most common method of screening for lung cancer is LDCT, or low dose computed tomography. And although there are some benefits, such as a statistically significant 20% reduction in lung cancer mortality for LDCT versus chest radiography, etc., there are some drawbacks such as false positive, false negative, and radiation risks. Next, Sadakierska Chudi, 2020, explains that miRNAs are non-coding RNA molecules. They have important mechanisms in regulating gene expression, and evidence indicates that miRNAs can influence physiological processes such as embryonic development, cell proliferation, differentiation, and apoptosis, as well as pathological processes, for example, tumor genesis, through epigenetic mechanisms. And last, QRT-PCR and Fireplex are two different quantitative analysis methods for plasma-based miRNA. Lang et al. 2018 and Liu et al. 2017 found the Fireplex assay to be more effective in cost plasma and had no extra limitations. Furthermore, using a panel of multiple miRNAs has been found to be more accurate. For my methodology, this is a secondary analysis of existing data. As I did not have access to labs and cohorts of people, I conducted a literature review from online journals, and these include PubMed, NIH, ScienceDirect, and clinical trials. As for my research methods, I first searched with general keywords like miRNA biomarkers, plasma biomarkers, liquid biopsy, and SCLC, just to name a few. This way, I found extensive research literature that I could eventually funnel down into the more specific articles. Then I branched out from each article and looked through those as well. So I have found that plasma-based miRNAs can indeed accurately diagnose SCLC in its limited stage. This could help combat the SCLC death rate because we see that the limited stage SCLC is more responsive to treatments. This means that when we accurately diagnose SCLC early, we can treat victims effectively. Secondly, there are many different ways that we can improve the accuracy of results, like I've explained earlier, Fireplex assays, and a panel of multiple miRNAs that both show more effectivity. My contribution is that I conducted a focused review of multiple literatures and analyzed findings to provide a study that brings in the best aspects of using miRNA, as well as recommends the standardization of the procedure of miRNA diagnosis. So in this study, the use of plasma-based miRNA biomarkers for the diagnosis of SCLC was reviewed using existing research. The results highlight that miRNAs can accurately differentiate SCLC from other diseases earlier and therefore provide accurate results. These findings underscore the potential of miRNA to be a solution for misdiagnosis of SCLC, which will help to provide people with more effective treatment since early diagnosis responds better to treatments. Despite these results, this surgery this study acknowledges limitations such as being subject to internet bias. Overall, the research concludes that finding new mRNAs could potentially aid in other diseases as well. So a few limitations that I acknowledge. All research was online, so there is a potential for internet bias. Um, Secondly, there are limited studies for SCLC, and also there is a lack of standardized methods. So even though it's not significant, there can be minor variations in results from each study to the other. And based on my research, I recommend the standardization of miRNA methodologies. I also recommend delving more into miRNAs to find new miRNAs and technologies. Finally, checking for multiple years after a diagnosis um, will be beneficial so we can crystallize the conclusion that yes, miRNAs not only diagnoses properly, but also provides a better result long term. Thank you.
Excellent. You want to share your experience with Gifted Gabber? You can stop sharing and speak.
Okay.
Yeah, you can go ahead.
First of all, I wanted to thank my professors, Dr. Prahlad and Dr. K, for encouraging me to learn a lot and providing me with like ample amounts of resources for that. With Dr. Prahlad teaching me about cellular and cancer mechanisms, and Dr. K for actually like teaching me how to write the paper, the process for writing the paper, it really helped a lot. I've never written a research paper coming here, and both of them contributed a lot. And I would like to thank Coach Joe and everybody else part of this for giving me this opportunity to write this research article and present it.
Thank you. Thank you, Monish. A question from Professor Prahlad.
Great job, Monish. Congratulations. So you mentioned that standardization is needed. So if I give you like $1 million and a lab, so how would you standardize? How would you go about
Well,
standardizing techniques?
so obviously we would look at existing research, and so existing research provides many different like components of it, such as to test against hemolysis, using QRT-PCR against the Fireplex assay, for example, using different panels of miRNAs, and using like different miRNAs in general. So I would like potentially test different like different components of those and see which ones like actually work the best, and to see which ones work long term, I would be a little more out and actually work with the larger cohort of people to actually see through with it and to ensure that it provides a better long term response.
Okay, great job.
Fabulous.
Thank you.
Fabulous. A question from Professor K.
Hi, Monish. We've worked a lot on your paper, and I know how much you're invested on this one. Yeah, and I also know that you have had some frustrations on the data, but then my question is, which of the current clinical trials do you find a lot more interesting?
So there was one clinical trial which there was a study that I found called Serum Exosomal mRNA predicting the therapeutic efficiency in lung squamous carcinoma. So this was the closest trial that I found. It wouldn't be the best one, but it definitely is the closest one. And this is the one that got me the most like interested. This focuses on the efficacy of serum exosomal miRNA as a biomarker for predicting the therapeutic effect of immunotherapy combined with chemotherapy. So even though it wasn't specifically for SCLC, I still like extensively read through it.
Okay, thank you. Congratulations, Monish.
Thank you.
Excellent. Let's go with Venu Dhanabal. Thank you, Monish. 2 questions for Monish. And I want to remind you that these are high school students presenting, and they're talking all kinds of high stuff that is beyond their age, and I'm super proud of them. Amazing. So, Venu, you ready? Venu, you're here? Can you hear me?
I'm here. Hello? Hello? Sorry.
Yeah, you want to turn on your video?
Yep. Is it on?
Let me just see. Do I see you? Yes, I do see you. Let
Okay.
me. Okay, I see you. Mhm.
Yes, I'm just waiting for my. All right.
Yeah.
Okay. Can you see my screen?
Yes.
Okay. All right. My name is Vinu Danabal, and today I'll be presenting my research on modulating interferon-stimulated genes through viral vaccines. But first, a quick introduction. Viral infections, especially influenza, COVID-19, and hepatitis, continue to pose a significant global threat, with over 40 million cases reported just this year by the CDC. Additionally, today vaccines are traditionally known for activating their adaptive immunity. However, recent research also shows they influence innate immunity, which specifically interferon-stimulated genes, or ISGs. This review explores how vaccine-modulated ISGs boost antiviral defenses and shape long-term immune memory. This raises my research question. How do different viral vaccine platforms modulate interferon-stimulated genes expression across immune cell types, and how does this modulation correlate with vaccine efficacy and safety? But to understand ISGs, now to get an understanding of ISGs, what are they? ISGs are genes that are activated by interferons. Interferons are cytokines released in response to viral infections. Key functions of the ISGs is to inhibit viral replication, promote antigen presentation, and activate immune cells, such as the natural killers B and T cells. They also serve as an important bridge between the innate response and the adaptive response by the immune system. And to get a deeper understanding of the ISG process, this diagram shows how the three types of interferons, if I can use my cursor, type 1, type 2, and type 3, all activate different but overlapping pathways that result in ISG expression. Type 1 IFNs, or IFN alpha and beta, signal through the JAK1 and TYK2, leading to phosphorylation of STAT1 and STAT2, forming a complex with IRF9 called ISGF3. This binds to the ISRE element in DNA. Type 3 IFNs, or IFN lambda, activate similar pathways and also result in ISG expression via the ISRE. Type 2 IFN, or IFN gamma, activates the STAT1 homodimers, which bind to the GAS element in DNA. The end result in all three of these cases is the expression of ISGs that enhance antiviral defense. And to get a deeper understanding of ISGs, we must understand the ISG responses across not just immune cells, but also non-immune cells. Dendritic cells are key sensors and messengers. They produce IFN alpha and beta and present antigens to the T cells, especially the CD8 plus cells, which are sort of like the managers and the war commanders. The macrophages and monocytes are early responders. They release cytokines and express antiviral ISGs like the RSAD2 to limit virus spread. Epithelial and stromal cells are critical at mucosal surfaces, like your lungs. They produce IFN lambda to drive localized non-inflammatory ISG responses. Natural killer cells, or NK cells, respond to IFN signaling by increasing cytotoxicity and producing IFN gamma, which help shape T cell responses. B cells support antibody production and class switching. ISGs help in their differentiation and function. T cells modulate their own activation and exhaustion via ISGs like PDL1 and USB18. Other innate cells, like the mast cells and eosinophils, they fine-tune the immune environment via the cytokines and histamine. Excuse me. And now for clinical trials that show the importance of ISG involvement. First, by Gotcha et al., is a study of the yellow fever vaccine. This trial showed a clear correlation between early ISG activation and later immune strength. This also helped validate ISGs as predictive markers for vaccine efficacy. Next is the Ebola vaccine. This study conducted by Berry et al. Highlighted how excessive ISG activation could signal overactive immune responses. The study also warned about vaccine reactogenicity and inflammation in vulnerable populations. Next, the mRNA COVID-19 vaccine by Arunachalam et al. Used single-cell transcriptomics to show which cell types upregulate ISGs after mRNA vaccination. This helped explain why mRNA vaccines trigger strong immunity really quickly. And finally, the BSG vaccine, it found long-term changes in monocyte behavior due to epigenetic changes in ISG expression. This suggests that vaccines can reprogram innate immunity beyond their target pathogen. And now the methodology that I used to kind of analyze these different clinical studies. My research focus was how viral vaccines modulate ISG expression across immune cell types and how that relates to efficacy and safety. I used PubMed, Google Scholar, clinical trials, and Science Direct. My keywords were ISGs, interferon signaling, viral vaccines, JAK-STAT pathway, vaccine efficacy, and trained immunity. Trials that were included were peer-reviewed articles from 2008 to 2024, studies measuring ISG expression after vaccination, and data from clinical trials or systems vaccinology analyses. The trials that were excluded were non-viral vaccines and reviews without original data and non-English publications. This project is based on a structured literature review. I analyzed peer-reviewed studies and clinical trials that investigated how different vaccine types, like mRNA, live attenuated, and vector-based, affect ISG expression. My sources focused on immune cell-specific ISG patterns and how those correlate with outcomes like immune protection or side effects. Now for my limitations. While my research shows that ISGs play an important role in vaccine responses, there are a few key limitations to be aware of. First, most studies only track ISG activations for a few days, so we don't know how long the effects actually last and the difference in effects as time goes on. Second, ISG responses vary between people based on age or genetics, so results may not be the same in every population and in every demographic. Third, there's a research imbalance. Most available data focuses on mRNA vaccines, so we might be missing some insights from other vaccine types. Fourth, some studies stop at gene expression. They don't track whether those changes actually lead to real-world protection. Finally, many papers just look at one part of the immune system, which means we may be missing how all the parts work together to create an overall systemic immune response. And finally, my conclusion and results. My conclusion is that ISGs are crucial for early immunity and help initiate long-term adaptive responses. Also, they are effective biomarkers for predicting vaccine success, vaccine efficacy, and vaccine efficiency. Understanding ISG modulation can help design better, safer, and more effective vaccines. Thank you. And I would like to thank Professor Parajuli for his extreme flexibility with the one-on-one meetings. As I'm sure he knows, I've been traveling for the past 3 weeks, like all of the US, and I'm really grateful that he was so open and adaptive to my schedule. And I was also like to thank Dr. K for helping me write my paper and put my thoughts and research onto a sheet.
Okay, you can stop sharing so that I can get Professor Prahlad on the screen. Okay, great job, Venu.
Thank you.
Yeah, great job, Venu. Congratulations. Yeah.
Thank you.
In your research, so what did you find? What kind of vaccine could be like most effective in inducing ISG response? Did you find anything? Were there any comparative studies or?
Sorry, what was the last
There are
part?
different types of vaccines, right? And mRNA being the one type, or that like whole organism, attenuated organism, that kind of pathogens. So that kind of vaccine, which
Yeah.
one could be more effective in inducing ISG?
My research found that mRNA vaccines tend to be the most effective at inducing a strong but also a broad ISG response, especially in like the earlier hours after vaccination. This was seen in studies using the single cell RNA sequencing, which showed high activation of a lot of ISGs in monocytes and in the dendritic cells. And I believe they trigger it so well because they mimic, like the mRNA cells, they mimic the viral RNA, which is recognized by the PRRs in the immune system, pattern recognition receptors in the immune system. Yeah.
Yeah, great job. Congratulations, Vincent.
Okay, a question from Professor K.
Hi, Venu. Congratulations on finishing your paper despite your busy schedule.
Thank you.
Okay, while reviewing all those literatures, what were you most frustrated about?
What was that? Frustrated?
Yes.
Okay. It was how inconsistent and short term many of the studies were. A lot of papers focused only on the first 24 to 72 hours after vaccination, which was one of my limitations, which is useful, like still useful, but it doesn't tell us much about how long ISG activation lasts or how it ties into actual protection weeks later. Also, many studies only looked at one or two immune cell types, even though ISGs are active across the whole immune system. And it felt like I was trying to piece together a big picture from very fragmented data. Yeah.
Amazing.
Excellent.
Yeah, great job. Great job, Renu. Next, let's go to Nirtana. That's such a nice name. Nirtana, are you here?
Yeah, I'm here.
Oh my God, you're so young. Which grade are you?
I'm in ninth grade.
Okay, wonderful, wonderful. Go ahead.
Hello everyone. So, this is my research topic. The efficacy and outcomes of bone marrow transplantation on patients with leukemia. I'm in grade 9 and I attend Briarwoods High School at Virginia. I'm also part of the Health and Medical Sciences Academy, which is located there. Introduction. So my topic area is the efficacy, complications, and long-term outcomes of BMTs, especially autologous and allogeneic on patients with leukemia. The objective of my paper is to evaluate and compare the clinical outcomes, relapse rates, and long-term complications associated with autologous and allogeneic bone marrow transplants in patients with leukemia. Writing this paper, I have like a personal connection for this topic. My aunt has leukemia and I wanted to write about this because I wanted to know more about what type of treatment she goes through and how it's done. So anyways, leukemia is a cancer of the blood and bone marrow. It's marked by the rapid growth of abnormal white blood cells that crowd out healthy cells and disrupt normal blood production. And in 2025, about 22,000 new cases of leukemia are expected in the United States, with acute myeloid leukemia or AML being the most common in adults and acute lymphoblastic leukemia more frequent in children. An autologous bone marrow transplant uses the patient's own stem cells, reducing the risk of immune rejection, but carrying a higher chance of disease recurrence. An allogenic bone marrow transplant uses stem cells from a genetically matched donor, offering a potential immune attack against cells. This is known as the graft versus leukemia effect, but with increased risks such as GVHD. This figure that I made is the concept of allogenic bone marrow transplants. And it talks about how stem cells are drawn from a donor and how they're separated and incubated with antibodies and then reinfused into the patient to repopulate the healthy cells. So here I have a chart of my clinical studies that are in the past 5 years or are ongoing. And some of my recent studies confirm that allogenic BMT is more effective for high risk or relapsed leukemia due to the graft versus leukemia effect, but it does carry higher risks of graft versus host disease and non-relapse mortality. Autologous BMTs offers lower toxicity and eliminates GVHD risk, but it's associated with higher relapse rates because it lacks the GBL effect. Innovations such as post-transplant cyclophosphamide, improved donor matching, and the use of targeted therapies are being integrated to reduce relapse in GVHD. Adoptive cellular therapies, including CAR T cells and NK cell infusions, are under investigation to enhance these anti-leukemia effects with reduced GVHD risk. Current research highlights the importance of individualized transplant strategies based on genetic risk profiles and minimal residual disease assessment to optimize the outcomes and minimize complications. And despite advances, relapse after transplantation and chronic GVHD do remain significant challenges, emphasizing the need for ongoing research and clinical trials to improve long-term survival and quality of life for leukemia. For my literature review, I used sources like PubMed, Mayo Clinic, and National Institute of Health. And I used articles that were published between the last 5 years. Methodology and results. So I've analyzed the data by systemically comparing clinical outcomes, relapse rates, and complications between autologous and allogeneic bone marrow transplant groups, using statistical methods to evaluate survival, relapse incidence, and the impact of variables such as donor type, age, and disease. Some results that I found was allogeneic bone marrow transplantation provides better long-term disease control for high risk or relapse patients with an 8-year survival rates around 54% and leukemia-free survival at 47%. But it does carry a substantial risk of graft versus host disease and higher non-relapse mortality. Acute GVHD occurs in about 47% and chronic GVHD in 52% of cases. Autologous BMTs results in lower early toxicity and virtually no GVHD, but relapse rates are significantly higher. For example, 3-year relapse after autologous transplants can reach 58% compared to 20%. And for unrelated donor allogeneic transplant, especially when performed in second remission. And this table that I made it shows the temporal events that can happen after transplantation. So it shows acute GVHD at the earliest median time of 17 days, and relapse at first remission at the medium of 237 days, and chronic GVHD and relapse phase and intermediate medians. So conclusion, my paper discusses comparative analysis on autologous versus allogeneic BMTs, recent advances in targeted therapies, CAR T cells, and post-transplant cyclophosphamide. Advances in transplant protocols, donor matching, and supportive care mean that findings from earlier cohorts may not fully reflect outcomes with current treatment methods. And while my paper does provide valuable insights and statistics regarding leukemia and BMT, it might not generalize to the public, again, because of donor matching and time of the transplant and stage of leukemia. Thank you so much. And now I would like to talk about how this program benefited me and how my mentors from this program helped me. So in my academy, it's called HEMSI, we learned about everything that Dr. Prahalad taught us, but Dr. Prahalad managed to teach it in like a matter of 3 classes while we took a year on it, and that was like very amazing. So hats off to him. And Professor K also helped me write my research paper and showed me the process on how to write it and went in detail. This is my first research paper, and thank you, Gifted Gabber and Coach Joe, for this opportunity. I'm definitely going to be back for more.
Excellent, excellent. Now let's have Professor Prahalad.
Hey, Nathan, a great job. Congratulations.
Thank you so much.
So you highlighted some both autologous and the allogenic bone marrow transplant have problems, right?
Yeah,
So
yeah.
did you find any strategies to make autologous or I think both types of BMT better? What are the strategies? Can you touch upon that?
Yeah, so give me a second. So to improve the post transplant outcomes and reduce relapse, there are several like strategies that are being explored. For example, immunosuppressive drugs like calcineurin inhibitors and mycophenolates are being used to control GVHD. This is by limiting the T cell proliferation. However, these drugs do have limitations, such as increased risk of infections and organ toxicities. So I think more research and more clinical studies need to be placed for, yeah.
Great job.
Yeah.
Congratulations.
Great. A question for Professor K. Yeah.
Hi, Nirtanov. Yes, we work closely with your paper, so I would like to ask questions. The question coming from Monish in this case, which is similar to what I would have wanted to ask from you. What challenges do you think still remain to improve the long-term outcomes of the transplantation based on your research?
So based on my research, like obviously everybody is different, and there are times where different rates of success for each type of transplantation is going to be different for everyone. And as like I said, there are more strategies to improve prognosis, like the immunosuppressive drugs that I've said. And yeah.
Excellent.
So
Yeah. Okay, great job. A big round of applause for Nirtana. Great job. 2 questions for him on the chat. Can we please have, Rakshit? Rakshit, are you here?
Yeah, one sec.
Yeah, go ahead, Rakshit.
Can you guys see it? Or
Not yet. Are you sharing something?
oh, one sec. Let me try one more time.
Yeah.
Is it available now?
Yes. You want to do the slideshow, huh?
Oh, yeah.
Okay, great. Can see it.
Okay. So hi all. My name is Rakshit Venkatraman. I'm in 8th grade and I'm a rising freshman at Lambert High School in Sewanee, Georgia. And my study is on the significance of a bone marrow transplant for non-Hodgkin's lymphoma and tailored T cells as a future solution. So in introduction, so NHL presents a significant challenge in modern day oncology, such as 80,000 plus new cases of NHL annually in the US, and there's a 30% relapse rate, meaning that it comes back after a diagnosis, and 65% survival rate for NHL. And bone marrow transplantation offers hope, but post-transplant immune recovery remains a critical challenge that tailored T cells approaches may address. And an overview of non-Hodgkin's lymphoma. The etiology of non-Hodgkin's lymphoma is not yet fully founded yet, but it's related to Epstein-Barr virus, is linked to 30 to 40% of NHL. HTLV1 causes 2 to 5% of global NHL cases, and hepatitis C infection increases lymphoma risk by 35%. And some demographics for NHL. Non-Hodgkin's lymphoma is the most common blood-associated malignancy worldwide, and it accounts for about 3% of cancer diagnosis deaths, and it ranks as 7th most common cancer, and accounts for 4% of cancer diagnosis, and ranks 6th highest in death rates among all cancers in the US. And there are common subtypes of NHL, such as diffuse large B-cell lymphoma, chronic lymphatic leukemia, and follicular lymphoma. And standard treatments approaches for lymphoma range from chemotherapy, administering drugs into the body to get rid of the cancer. And the most common type of combination is R-CHOP, especially for NHL. And the second line of defense is radiotherapy. using energy beams to destroy cancer cells, and this often follows doses of chemotherapy targeting lymph nodes and other areas in the lymphatic system. And most importantly, a bone marrow transplant. This replaces damaged stem cells with healthy ones from the patient or from a donor. Stem cells derived from the patient are called autologous, and from the donor are called allogenic. And a bone marrow transplant often happens after subsequent doses of chemotherapy and radiation damage to the bone marrow. And the significance of a bone marrow transplant for NHL. Bone marrow transplant represents a critical therapeutic intervention for patients with aggressive or relapsed NHL and effectively replaces damaged T cells in the body. But the bone marrow transplant also carries significant risks, such as GVHD or graft versus host disease. This is when, during an allogenic transplantation, the host cells and the donor cells fight each other. And another adverse effect is known as iron deficiency anemia. And this happens during a bone marrow transplant failure and reduction of blood cells in the body. But the integration of BMSCs, bone marrow stimulants, and tailored T cells proposed by myself can improve a patient's outcome in the long run. So BMSCs, or bone marrow stromal cells, are cells that have a crack at regenerating blood cells. And as you can see on the picture on the right, they separate into many types of cells: bone marrow cells, blood cells, and others. And some benefits are they support blood cell development, activate growth promoting pathways, enable intercellular communication. They release proteins and RNA containing exosomes, enhance immune system functions. But some risks are blood clot formation, tissue scarring, potential tumor support, infusion complications, and immune system suppression. And these are bone marrow stimulants. So bone marrow stimulants are crucial for preventing transplant failure, which can lead to iron deficiency anemia. And these therapeutic interventions mimic the body's biochemical signals to enhance blood cell production, and it is administered in doses exceeding natural levels. And these stimulants can significantly improve outcomes following bone marrow transplantation and reducing the risk of infection and disease that patients face during recovery. So this is my case study / literature review. In the first case study, a study by Mochel, Ennis, and others sought out to describe the different long-term outcomes of autologous hematopoietic cell transplantation for NHL. The study concluded that there's a 78% survival rate for diffuse large cell NHL, 77% survival rate for follicular NHL, 85% survival rate for non-blastic Burkitt NHL, and 52% survival rate for mantle cell NHL, and 77% survival rate for other NHLs. And this is post-transplantation. And my second case study, a study by Kinoshita and others, used TAA T cells for tumor relapse after allogenic bone marrow transplantation for acute leukemia similar to lymphoma, and donor-derived TAA T cells therapy was well tolerated and showed that only one patient developed GVHD. And this shows that my proposition of engineered T cells is not too far off, and similar strategies have been used in the past. And my third case study, this is a study by Falkenberg and others, and examines the dual role of donor-derived T cells in allogenic stem cell transplantation, and it highlights their therapeutic benefits that are against the risks. And donor T cells are essential for mediating the graft versus tumor, or GVT, effect provided by GVHD. And one key approach involves T cell depletion from the donor graft, followed by delayed infusion of T cells after transplantation. So this delay allows the recipient's inflammatory microenvironment to stabilize, and this lowers the risk of GVHD. Another strategy is the use of selective T cell therapies, which involve isolating and expanding T cells that are specific to different types of antigens. And these targeted T cells aim to retain anti-tumor and antiviral activity without broadly attacking normal host cells. And this again shows that my proposition of engineered T cells is not too far off. And these strategies used in this third case study can be used in my engineered T cells. And some results that I've found are that BMTs have proven as a well-rounded option for NHL or related diseases, but can lack in different ways. And factors such as bone marrow stimulants and BMSCs are options battling BMT's shortcomings, but have common symptoms. Also, effects like GVHD after allogenic BMT is not yet curable, but can be solved by using different T cell therapies or tailored T cells. And T cells have been used before, such as GVTs and TAA T cells, and this is not a far off proposition. And this is my methodology. So the limitation is this study is based on secondary accounts and not primary, so no clinical trials have been self-initiated. And this proposition is also specific, and no exact trials are available, although there are similar trials. And I have collected over 30 studies to come up with this proposition. And some peer-reviewed journals I use are NIH, American Cancer Society, and Lymphoma Research Organization. And clinical trial databases such as clinicaltrials.gov have been used. And evidence-based medicine databases such as PubMed have been used. The inclusion criteria for this study is that it focuses on non-Hodgkin's lymphoma patients post bone marrow transplantation, and all trials investigated are published within the last 10 years. And the exclusion criteria are no non-blood related malignancy BMT evidence is shown, and animal studies have not been included. So as a conclusion, in my research paper, I have sought out to figure out the significance and importance of a bone marrow transplant for non-Hodgkin's lymphoma and corresponding types of non-Hodgkin's lymphoma. The BMT has proven as a great solution for replacing damaged stem cells in the bone marrow, but also come with drawbacks such as GVHD and BMT failure resulting in anemia and low blood cell count. This is where factors such as BMSCs and bone marrow stimulants try to solve these problems, but these cells also have adverse effects, yet not much. However, engineered T cells, a self-made proposal, will aid as an extra option for patients, but also in aid to fight GVHD, as evidence has been found in use of combating the GVT effect caused by GVHD. And this is a short prototype, not yet finished, but a short prototype of what my engineered T cell will express. So first, to combat GVHD, we'll use all strategies proposed in the third case study and also in the second case study, and they'll express interleukin-7 and interleukin-15 cytokines to support the survival and expansion of memory and cytotoxic T cells without significantly increasing GVHD risks. Tumor-specific receptor targeting antigens such as CD19 and CD123 enable precise elimination of malignant cells so that the cancer cells do not stay in the body and give relapse. And these also preserve the GVT effect while sparing health tissue, meaning that GVHD is not a problem with these antigens. And finally, limiting the expression of pro-inflammatory cytokines through regulatory promoters and inhibitors. Receptors like PD-1 further reduce the likelihood of immune-mediated tissue damage. And finally, I would like to thank Professor K and Professor Prahlad for their invaluable guidance through my research journey. Professor Prahlad has really helped me through my study and understanding NHL and bone marrow transplants, and Professor K has really helped through writing my research paper. I would also like to thank Coach Joe and the Gifted Gabbard team for giving me this experience. Thank you.
Fantastic. Thank you. We'll have a question from Professor Prahlad.
Hey, Rakshit, great job. Congratulations. Okay.
Thank you.
So a couple of comments before a question, okay? Since you're talking about bone marrow therapy, so in one of the slides you said bone marrow stromal cells are used. It's not stromal cells, it's stem cells, okay? So BMSDR is bone marrow stem cells. And the second thing, you're saying case studies, okay? Case studies in medical terms, actually, when they see a unique patient, one patient with some unique characteristics, only one patient, okay, and publish on that, that's called a case study, okay? So in your case, those are clinical studies where multiple patients are involved, okay? So say clinical studies. So now my question is about your T cells. You're talking about T cells to improve bone marrow therapy outcomes. So how do you engineer the cells? Interleukin-7, interleukin-15 are enhancing the memory response, right? So how does it improve bone marrow therapy response though?
So basically, interleukin-7 and interleukin-15 can support survival and expansion of memory, but these can be helpful when basically for the immune system, also as helping expansion of blood cells in the immune system.
Okay, so you may need your thing sounds more like CAR T cells, though, okay? If you're specifically targeting, so maybe we will talk about, I'll put comments in your thesis. Okay, great
Okay.
job though. Wonderful.
Thank you.
Congratulations.
Yeah, a question from Professor K.
Okay. Hi, Rakshit. I know you were most worried about the fact that you wanted to conduct this study, but you are still on eighth grade. And you are worried that somebody might be doing similar research that you wanted to pursue. But moving forward, what if like 4 years, 5 years from now, when you do your own clinical trial on this one, what if you or somebody already has conducted the research that you have been what are you gonna do moving forward?
So you're saying that if others have already done it, what would I do moving forward?
Yes,
So I
considering that
would,
you are still on eighth grade.
yeah, so I would like to at least contact them and share similarities and differences between the studies because there should be some similarities and differences, and maybe do a case study together showing positives and negatives of each study and how to improve based on those events.
Excellent.
Excellent.
Yeah. Thank you. Thank you. I mean, Rakshit, being in eighth grade, you're phenomenal. So keep up the good work and continue with your research. Okay, so we're going to go with Soha. I hope I've covered everybody in the cancer research. Soha, you want to go ahead, honey?
Yeah, sure.
Okay, Soha, go ahead. Yeah, there you go. And welcome AI researchers. We have Soha. You're going to learn about cancer really quick. Please hang in there. We're just running over a little bit. We will get done and we will start our AI thesis defense. Thank you for joining in. Yeah, go ahead, sweetie.
Just give me 1 second. Can you see it?
Yes, perfect. Yes.
Okay. So my topic was basically
Sorry to interrupt you, but it has the notes in there. You want to make it, yeah, make it like, sorry. Yeah. Yeah, but present and present. Right there. Yeah. Excellent.
okay, yeah.
Good.
So my topic is what factors impact cognitive development and how do we respond in a way that is receptive to all? My name is Soha Sheikh. I'm in 10th grade at Shrewsbury High School in Massachusetts. So I'm basically talking about how people respond to new ideas and topics, especially after they've been taught something completely different. A lot of it is in older people. It applies to these type of situations, smoking and vaping in lung cancer, lack of sunscreen usage in melanoma, vaccines and the myth that they cause autism, and radium poisoning in factories in the 1920s. All of these have dangerous consequences that can be prevented and avoided with less misinformation and more thoughtful personal research on the topic. I'm less focusing on how to cure any disease and conditions and more on prevention of multiple disease and conditions. Yeah. So my literary review, I found a couple articles. These are two that I thought were most in line with what I'm trying to do. So the environment, enrichment, and cognitive flexibility It highlights the effects of the environment on the ability to learn new ideas and adapt to different situations, and shows how stimulating different environments and more empathy in your childhood can lead to more cognitive flexibility later in your life. Same goes for the second one. It shows how adaptability and flexibility is crucial for learning and problem solving. So why isn't all of the information equally welcoming when we're exposed to it? One big topic is the fight, flight, or freeze response, which is a natural response to danger, but it can also kick in when someone's intelligence feels like it's being questioned or insulted. It's an auto response, and when it kicks in, it's not overseen by any like decisive brain functions anymore, which can be a real issue when you're trying to teach people about new situations and ideas. So specifically in the brain, there's different genes and parts of the brain that control decision making and how we respond to new ideas. The prefrontal cortex is responsible for decision making and reasoning and self-control. The ability to reason with new ideas makes someone more responsive to them and able to learn them. The amygdala is responsible for the danger sense and like threat, which when triggered can lead to that flight, fight, or a freeze response I was talking about earlier. And so by not triggering these when we're giving information to people, it can make them more receptive to it. And the hippocampus, it is in charge of memory and experiences, and those can make people feel different when talking about, when talking about new ideas, the experiences that people have affect how they retain new information. Specific genes that control cognition, I found three main ones: COMT, BDNF, and CRNA4. COMT breaks down dopamine in the prefrontal cortex, and it can influence executive function and working memory to make you think more about what you're good doing before you do it. BDNF supports the growth of neurons and survival, and it can affect memory and learning and how the brain responds to new ideas and adapts to them. And this last one influences attention and learning by reacting to the stimuli and processing it. It can be helpful when trying to understand why people are more receptive to new ideas, whereas some people are not. The environmental elements are very important in this type of study because a lot of genes, especially if you're not looking for like any invasive procedures, they can be harder to fix or solve these situations, but environmental elements such as social support, ignorance or self-righteousness, external false information, culture, and psychological safety can all be great factors in how responsive a person is to new information. For example, social support. People enjoy following trends. So if the majority of people see something that they see follow one thing, like a diet or activity or a purchase, they're going to want to follow and be part of the group. This can be a negative thing when the trend is something like smoking or not wearing sunscreen, or bullying. But if it's something positive, like donating food, dressing nicely, joining social events, it can be helpful to society as a whole. Ignorance and self-righteousness. Basically, if someone believes that they can't do or be wrong, they aren't going to want to change and understand new ideas, even if it's like trying to be pushed in their faces. They often won't listen, and it can make prevention of harm that someone is trying to do harder because they don't want to listen. External false information. Things like social media, biased news sources, and not reading into the news can blind people when they just believe whatever they come across. So, and especially because it's all over the place, all around us, in this day and age, it's harder to relearn something that you've already been taught from the wrong source. Um, when talking about culture, everyone has a culture, and this plays a huge part in how responsive people are to ideas. Because if people that they know, their family, friends, and everyone from their culture, they're gonna listen to them more rather than some news article or like doctor that seems like strange or foreign. They believe like what's familiar to them, so the unfamiliar seems unrealistic and untrustworthy. It's ingrained through people through generations. So breaking off from a belief that you've just grown up with can be difficult than believed. And finally, psychological safety. If someone feels like they're being attacked, they're more likely to go into a fight, flight, or freeze state and not focus on taking in new ideas, which makes being receptive to different ideas harder. When talking about the methodology, it was all qualitative because you can't exactly measure how responsive someone is to a certain idea with numbers. It's a very like social interaction, and I found two methods that I responded liked well. This first method was from these are both from clinicaltrials.org.gov. So this first one is a 15-week plan with older adults, where they taught like half of them different factors from their childhood that they could implement later on. So it's basically like classes, and then they took responses before and after from both groups to see if their experiences in those classes improved how they thought and their thinking processes. The second one was a trial for adults, like middle-aged adults, and it was an integrative body-mind training for mindfulness and being more present in what you're doing. It showed a lot of improvements in stress levels and self-control in brain plasticity. Strategies to improve cognitive function when learning. Generally, people aren't going to constantly do this, but by practicing, it can make learning more available for everyone to listen to. Mindfulness and meditation can make people have a cooler head, which leads to a more productive discussion. Psychological therapy can help while talking to someone unbiased. It leads to rethinking your own actions and deciding for yourself what you're doing, and it can also unpack traumas and deeper beliefs in your childhood. Intentional exposure to new ideas allows you to see everything, all pieces of the puzzle, and make your own educated decisions instead of just relying on someone else's. This also leads to being against censorship and covering up experiences and studies instead of just being in your own protective little bubble. Practicing empathy regularly is very important, not just in learning, but it can putting yourself into someone else's shoes can help think you through your environment and make sure you aren't letting your emotions blind you from facts. So this is like basically my conclusion. Just like how Rome wasn't built in a day, science as a whole can't make so much progress in a short amount of time, but by practicing and contributing as much as we can allow everyone to make their own decisions and allow a lot more prevention of conditions and illnesses rather than solving them later on, and focus on saving as many people as possible. Thank you.
Okay, great presentation. You want to stop sharing so that Professor Prahlad can ask a question?
Yeah, great job, Soha. Congratulations. So, did you find any genetic association with those studies? Why people don't learn one and versus who learn better?
Yeah, not really. Most of them were relying on the environmental aspects of it. And so if I was going deeper into the study, I would want to search more about the genetic aspects to see if any like epigenetic fixing can be done like in a person's head. But it was mostly based on the environmental factors, as that's a big part of how someone grows up. It's also the case of nature versus nurture. Um, yeah.
Probably look into epigenetics. Okay.
Yeah.
All
Yeah.
right. Great job. Congratulations.
Thank you.
Okay, great. Can Professor Prahlad, I'm sorry,
Yes.
Professor K, a question from you?
Between genetics and the environmental factors, well, based on your research, which do you think has the most impact, or were you able to find enough information to make comparison?
I definitely think, based on my research, that the environmental factors have a greater impact, especially because the way someone's raised can greatly affect how they respond to information later on in life. And even changing like small little bits and pieces later on in your life can improve your cognitive ability and what you think of.
Excellent. Excellent. Let's have Aditya. I apologize to I'm sorry, I apologize to the AI students. We are just running over, but please bear with us. This is the last student. You are going to learn, right, from these kids. So Aditya, where are you? I'm just going to pin you. Okay. Thank you for your patience, Aditya. Go ahead. Do you have issues sharing your screen? You can share it with me and you can put it in the chat and I'll share it. Is that a issue that you're encountering, honey?
Yeah, I'll just share in chat.
Yeah, I will share the screen. Okie dokie. Let me just check this. Okay, honey, you need to give me access. I don't have access to that. Giftedgabbers@gmail.com, or you can just say anyone can get access to your presentation.
I share a PDF.
Okay, got it. Let me just check the chat. Sorry, what was that? You can download it as PDF.
Mm-hmm.
Did you download it?
Yes.
You need to share it with me. You want to upload it to the chat?
Mm-hmm.
Okay, so let me just go there. One second. Okay, so I got it. I'm going to share my screen. You can speak. Okay. Here you go. Yes, go ahead.
Um, Hello, I'm Aditya Nantapali. I'm a freshman at Lafayette High School, and I'm going to be discussing xenotransplantation, which is a current medical breakthrough. And I'm going to be going over kind of a few key components of it. Can you go to the next page? Okay. There should
Okay.
be.
Mhm.
So what I want to talk about is the process of xenotransplantation, which is basically when people use genetically modified organs from other species and they use it to transplant organs to organisms of other species. So in this case, the organs of genetically modified pigs into humans. So I'm going to be talking about how it's more beneficial than regular transplantation. And there are a few key questions like how is it better and how is it worse? And additionally, the main kind of idea of this paper is how it affects the livestock industry. So this review also explores the social and ethical issues associated with xenotransplantation. Can go to next page.
Yeah, I'm sorry. Literature review, am I on the right place? Go ahead.
Yeah. So currently, researchers have proven that allogenic transplantation or transplantation between the same species is kind of impractical because it has the risk of spreading infections. And in my research, I haven't found much about the spread of infections about during xenotransplantation, but I have noticed a lot of cases of infections and diseases spreading from allogenic transplantation. Additionally, there's the transplant list, which is not working very well now because since there's a big increase in the amount of cancer in the population, so the list doesn't have very many organ donors compared to the amount of people requiring the transplants. So that's one of the major issues. So xenotransplantation can actually fix that because it can broaden the amount of available organs. Additionally, there's gene modification, which is used on the organs to make them more humanized, basically. And basically, while the pig is an embryo, they change the genes of it. And one major kind of process that helps this is 3D bioprinting. So typically, when they change the genes of a pig, they have to wait for it to be fully mature to then harvest the organs. And this is the only way to test if the gene editing was actually successful. But with 3D bioprinting, it kind of uses the technology that is used to print organs, and it can print the organs with the gene modifications. So it's a lot faster and it saves a lot of money in this process. So there have been a few xenotransplantation procedures, but a lot of them don't have lasting success. So the current procedures that have been done, there's not a lot, but people have kind of researched all there is to them. But right now, there's still kind of room for more improvement in this. So a lot of the information I gathered was from PubMed. But PubMed doesn't have a lot on xenotransplantation, so I had to use other resources like clinicaltrials.gov and the FDC website and so much more. A lot of the articles have shown that after the clinical trials, the length of survival for patients each time has been increasing. So originally, the body used to reject the organs immediately, but now using improvements in gene editing, the body can actually accept the organs for longer. So, for instance, using CRISPR, they're able to splice the genes and either remove the negative parts of it or add their own modified genes. And this has been implemented before. So, in one clinical study, a person had a pig's kidney implanted into them, and they removed the alpha gal gene, and this kind of helped it not activate the immune system, and it helped the body accept the organ. So there have been a lot of improvements in xenotransplantation, but there have also been a lot of ethical issues because people don't like that the pigs being used don't have any say in this. So we're basically using the pig's organs without their approval, which doesn't really make sense, but it's what a lot of people are worried about because we're basically using them and they're getting nothing in return. But gene editing can also help produce better livestock, and it can actually improve the kind of growth rate. It can improve the meat quality and so much. So the conclusion, there's actually like a few key questions I'm going to answer. So how is xenotransplantation better than allogenic xenotransplantation? So xenotransplantation currently can help with all the issues with regular transplantation, the donor list, and the kind of infections that are caused by transplantation, and even making organs more suitable to the body. Because with allogeneic transplantation, it's really rare finding organs that are compatible to a singular person. But with xenotransplantation, it's only a matter of time until we're editing the genes of an organ to match a specific donor. And how does the public feel about this? So people might think that a lot of people don't want the organs of animals inside them, but actually the thing they're most worried about is the conditions the pigs live in. So currently the pigs are born and raised in facilities where they go through testing each day, and people don't think this is very humane as the pigs are not treated very well. So what they want is just better conditions, and that will kind of get rid of all their concerns about this. And how do these processes affect livestock? Well, gene editing can help many livestock workers by boosting the efficiency of their jobs. So one modification that people can make to the genes of these animals is they can improve the growth rate, which is used to have better organs. So a pig of 2 months old can have organs that can support a fully grown adult. And these modifications also help produce meat faster, and they produce better quality meat. So that helps the livestock industry a lot. Most articles focus mainly on the key parts of xenotransplantation, but this article kind of goes more in depth on why it's more beneficial and why it can be not a replacement for allogeneic transplantation, but it can be used hand in hand with it. Because there's still problems with both, but this kind of covers the problems of allogeneic transplantation. And this paper also goes over more on how it affects industries outside the medical field, which a lot of other papers don't. But there are a lot of not a lot of limitations, but one major limitation is the amount of cases and information available. Since xenotransplantation is a very new topic, there have not been a lot of cases on it. A lot of articles kind of go over the same few cases, so it was hard finding a lot of variety. But soon more cases will come through, so that will be a lot easier to get more information in the field. But currently, it was kind of hard in getting new inputs because it took a while to find 4 cases of xenotransplantation, but that's pretty much the only issue with this. So as it like gets more popular and more in use, it'll be a lot easier to find this. Okay, so now I want to thank the professors and everyone else. Um, Professor Prahlad, he kind of like helped me through all this. I've been falling behind a lot, but with his support, I was able to finish everything on time. And then Professor K, she kind of introduced me to an entirely new style of writing. This is my first time doing any sort of like research and writing anything about it. So she helped me a lot, and she also helped me in picking the topic because this is my third suggestion on what to research on. But the first two, now looking back on them, I realized that I wouldn't been I wouldn't have enjoyed working on them as much as I enjoyed this. So she kind of led me to choosing this. And I also want to thank everybody else because they really provided the kind of resources to do this. Yeah.
Great job, Aditya. Thank you for sharing your thoughts. Let's get Professor Prahalad to ask you a question.
Great job, Aditya. Congratulations.
Thank you.
So you mentioned so multiple organs can be taken from the pig, like for xenotransplantation, pancreas, heart, kidney. So in your research, what did you find? Which organ is most compatible for transplant, one versus another, and any idea why?
So in my research, the articles I found mainly focused on the heart and kidney, as they're able to be kind of more humanized, more compatible with the human body because they're kind of similar. So there's like a basis that people can start on to modifying them.
Okay, yeah, thank you.
Excellent. Great topic, very, very interesting. A question from Professor K.
Hi, Aditya. I know you're having difficulty looking for articles on this one or researches on this one, but despite that one, you were able to establish that xenotransplantation is very promising. But I want to ask, what was your biggest, what is the biggest obstacle with xenotransplantation based on your research, despite its promise?
The biggest obstacle, I'd say it's mainly on getting the body to accept the organ, because right now the organs have all the antigens that activate the immune system. So organ rejection is currently the only end result of this. So that's one like the main problems that's going on.
Great job. Yeah. Thank you. Thank you, everyone. All the cancer students for being here. I mean, it's hard to believe that these are high school students. I always learn a lot from them, and they come in as a cocoon and leave the program as a butterfly. And thank you very much, Professor Prahalad and Professor K, for mentoring students and my whole team. And I want to give a big round of applause for all cancer students. Your job is not done. It's just the beginning. We are going to submit our GSR. All the best on your AP exams, and we will connect back. Okay, so any questions, let us know. We are here to support you. Okay, a big round of applause to all my cancer students. Okay,
great job, guys. Congratulations.
Yes, thank you, everyone. I'm going to let you go. The AI students, please stay on.